Today we're looking at problem solving in data analysis, practice test 1. There are 17 questions. Number 1. John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? So for choice A, between 0 and 30 minutes, we see that the heart rate goes up and then it flatlines. So it's not correct because it's not strictly decreasing. For choice C, between 50 and 65 minutes, we see that it goes down and then up, so it's backwards. That's why C is wrong. And for choice D, between 70 and 90, we see that it flatlines, then it goes up, then it flatlines again, which is not the pattern of strictly increasing and then strictly decreasing. However, if we look between 40 and 60, we go straight up, then straight down. That's why B is correct. Number 2, if y is equal to kx, where k is a constant, and y is equal to 24 when x is equal to 6, what is the value of y when x equals 5? So the first thing to notice is that we can substitute what y is equal to and what x is equal to into this original equation, and we get 24 is equal to 6k. This allows us to solve for k. When we divide by 6 on both sides, we're left with 4 is equal to k. If we rewrite our original equation, y is equal to kx, now we can plug in for k and we can plug in for x, and this will allow us to solve for y. So in other words, y is equal to 4 multiplied by 5. So y is equal to 20. Number 5. Which of the following graphs best shows a strong negative association between D and T? Association measures how closely a spread of data follows a line. For example, here in A, if this was my line, the dots are all over the place. Many of them are far away from it. And for B, if this was a strong increase, well, it's not matching the line. But for C and for D, the lines follow pretty closely the dots. So which one represents a negative association? That would be D. Number 6 is a converting units problem. A hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? We can begin with 2 decagrams per 1 container. And we know that our eventual unit we want to end up with is milligrams. So how do we cancel out decagrams? When we're converting units, here, decagrams is on the top of the fraction. To cancel it out, we want to put it on the bottom of the fraction. So if I multiply this by 10 grams per 1 decagram, my units, decagram and decagram, cancel out. I'm still not there yet because I have grams and I want to get to milligrams. So I multiply by the other conversion rate from our table, and grams is on top and on bottom, so these cancel out. The only thing left to do is to multiply straight across the top and straight across the bottom. The bottom should be pretty easy as it's 1 times 1 times 1. And 2 times 10 is 20, times 1,000 is 20,000. Number 7. The number of rooftops with solar panel installations in 5 cities is shown in the graph above. If the total number of installations is 27,500, what is an appropriate label for the vertical axis of the graph? To identify total installations, we can count up the value for each bar. In City A, for example, there were 9 installations. For B, 5 according to this y-axis. City C had 6, D 4, and E 3.5. If I added all of these together, I'm going to get 27.5. So how do I get from 27.5 to 27,500? The correct answer is that I use a scale that I'm counting in the thousands. That's why this one was C. Number 12. Based on the histogram above, of the following, which is the closest to the average or arithmetic mean number of seeds per apple? Normally, to figure out averages, we add together all of the possible values and divide by how many. Notice there are only 1, 2, 3, 4, 5 bars for 12 apples. So how do I add them up? You have to understand how a histogram works. This bar above 3 corresponds with 2 apples. So we add 3 twice. We add 5 4 times. We add 6 only once. 7 we add twice, and 9 we add 3 times. All of this gives us 73. We divide by how many apples, which is 12, and we get a decimal, but it's really close to 6. Number 13. A group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. Which of the following categories accounts for approximately 19% of all the survey respondents? So the key part of this table is the bottom right, as that is the total of the totals, which represents how many students took the survey. If 310 students were surveyed, and we're looking for something, for some category that accounts for 19%, how do I take 19% of 310? The correct answer is I multiply by 0.19. This gives me 58.9. So then I'm going to check each area. Females taking geometry, 53. Females taking algebra 2, 62. Males taking geometry, 59. And males taking algebra 1, 44. And which one is closest to 58.9? C. Number 14. The table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? So essentially what we're doing is we are crossing off this 24 and we are recalculating. So let's consider these one at a time. To find the mean, I would add up all of these numbers and divide by 21. Without the 24 included in the data set, I'm going to add up all of these numbers except for 24 and divide by 20. This will lower the mean slightly, but not very much. If I consider median, typically, to find the median, I would cross off the smallest, cross off the biggest, cross off the smallest, cross off the biggest, till I find the middle number of 12. Without 24, it's still going to be 12. It's not going to change at all. The biggest change here is with the range, because I go from 24 minus 8 to 16 minus 8. So my range actually is cut in half. That's why C is the best answer. 17. The complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? So let's review function notation. Y equals x is the standard equation for our coordinate system that we learned in Algebra 1. Later in the year, we look at this instead as f of x is equal to x. So you put in some value x, and f of x is what you get out of the function. If we're looking at an individual coordinate, we might consider it as x, comma, f of x. This is relevant here because they ask about for what value of x is the value of f of x at its minimum. So the minimum y value is here. And they're asking for what value of x is this the case. So we go on up to our x-axis, and the answer is -3. Number 20. Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount she paid to the cashier was P dollars, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? So let's set up two variables as we create this problem. The price paid, we're going to use P, and the original price, we're going to use X. So the original price, X, was multiplied by 0.8. That represents a 20% discount. I take 100 minus 20 to get 80, and since I'm converting to a percent, I move the decimal place over, and I get 0.8. Then I'm going to multiply this by 1.08, which represents the sales tax. 100% of the original price plus 8% extra. And this is all equal to the price paid. So again, original price multiplied by a discount multiplied by a sales tax equals price paid. The question asked me to represent the original price in terms of P. So in other words, they want me to solve for X. So what I can do, I can divide both sides by 0.8 times 1.08. And here on the left, this is all canceled out. I'm left with just X, the original price. And on the right, this P is equal to 0.8 times 1.08 on the bottom of the fraction carries down. So the answer is D. Number 21. The data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what is the probability that the person belonged to group Y? Another way to think of this is that on the top of my fraction, I'm going to include all of the students, or all of the people that had at least one dream and, or plus, they were in group Y. Where on the bottom of the fraction, I'm going to include all people that had at least one dream. So if we look at our different categories, none does not fall into at least one dream. But both 1 to 4 and 5 or more do. So to set up our fraction, we're going to put 11 plus 68 on the top, because in the group Y row, those are the number of people that had at least one dream. And on the bottom of the fraction, we're going to add 39 and 125, as those are the people that had one or more dream in either group. When we complete this addition, we get 79 over 164. That's why the answer is C. Number 22, which of the following best approximates the average rate of change in the annual budget for agricultural/natural resources in Kansas from 2008 to 2010? So this is a slope problem. We are calculating the difference in these two values and dividing by how many years. So if I was to consider y2 minus y1 over x2 minus x1, I can use this formula to find my answer. Interpreting my table, I'm going to consider the year, such as 2010, as my x-coordinate and the budget as my y-coordinate. So I take the larger budget from 2010 and I subtract the smaller budget from 2008. And I subtract the difference in years on the bottom of the fraction. This gives me 130,000 or so divided by 2, which is why the answer is B. For number 23, of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to the Human Resources Program's ratio of its 2007 budget to its 2010 budget? So this is how we'd figure out the ratio for human resources. You could either take 2007 divided by 2010 or vice versa. As long as you are consistent for all of the different programs, it will work. I chose to take 2007 on top. And we can almost ignore most of these numbers as they are not particularly significant digits. And I'm going to think of this as 4 million over 5,900,000, which is really close to 4 million over 6 million, which I can reduce to a ratio of 2/3. So if I compare agricultural/natural resources budget ratio, I'm taking 373,000 divided by 488,000, which is not 2/3. If I look at highways and transportation, if I set these two up as a ratio, it's not 2/3. Similarly, for public safety, if I set these two up as a ratio, it's not 2/3. But for education, 2 million or so divided by 3 million or so definitely has a similar ratio to 2/3. The same trick, I only look at the most significant digits, and I'm looking at 2/3. That's why B is the best answer. Number 26, Katerina is a botanist studying the production of pears by two types of pear trees. She noticed that type A trees produce 20% more pears than type B trees did. Based on Katerina's observation, if the type A trees produced 144 pears, how many pears did the type B trees produce? From this underlined phrase in red, I can create the following equation. A is equal to 1.2 times B. Then I can substitute 144 in for A, and I'm left with 144 is equal to 1.2 B. If I want to solve for B, I divide both sides by 1.2. And my answer is 120. 27. A square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is square and has side lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table below. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? So each of these regions has an area of 1. The dimensions are 1 by 1, so the area is equal to 1. But if I consider the entire field, the dimensions are 10 meters by 10 meters. So the area is equal to 100. And that's what I'm going to have to multiply to figure out the earthworms in the whole field. So if I was to take the average number of earthworms for each of these regions, it comes out to somewhere around 147. And since I'm multiplying that by 100, I move the decimal place 2 to the right, meaning I add 2 zeros. And the closest answer is C, 15,000. Number 33. According to the line graph above, the number of portable media players sold in 2008 is what fraction of the number sold in 2011? So here in 2008, I had 100. In 2011, 160. So if I set this up as a fraction, I can get rid of the zeros. That's effectively dividing both by 10. And I look for common factors like 2 in both numbers. This reduces the fraction, and the lowest form, 5/8. Number 34. A local television station sells time slots for programs in 13-minute intervals. If the station operates 24 hours per day, every day of the week, what is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? So Tuesday and Wednesday represent 2 days. And I'm going to multiply this by a conversion of 24 hours per 1 day. That way I cancel out this unit of days. To cancel out hours, I consider how many programs are there per hour. 2 programs per hour. Now it might be tempting to use 30 minutes instead of programs, but that's going to complicate the situation a little bit. We can leave it simply as crossing out hours, and already we can get to our answer. 2 times 24, 48, times 2, 96.